car is moving at 60 kilometers per hour. Simple, but here's the question. Moving compared to what? It sounds trivial, but it isn't, because the way you think about motion is probably incomplete. Let's start with something familiar. You're sitting inside a bus. The bus is moving smoothly down the road. You toss a ball straight up. It goes up and comes right back down into your hand. Nothing strange. It feels normal. But think about it. The bus is moving forward. So why didn't the ball fly backward? Why did it come straight back to you? That's the first crack in our intuition. Now imagine someone standing outside the bus, watching. From their point of view, the ball doesn't go straight up and down. It moves in a curve, forward with the bus, while also going up and down. Two completely different descriptions of the same motion. So which one is correct? The answer is both. And that's where things start to shift. Motion is not absolute. It depends on who is observing and what they're comparing it to. Now let's push this idea further. Imagine you're inside a completely sealed train. No windows, no sound, no vibrations. You toss a ball up. It comes straight back down. Everything behaves normally. Can you tell whether the train is moving or standing still? If the motion is smooth and constant, you can't tell from inside. There's no simple experiment you can do to detect that constant motion. This is a very deep idea. It means that constant motion and rest can look exactly the same from inside a system. There's no special label that marks one as truly at rest. Now pause for a moment. If you can't tell whether you're moving, what does it even mean to say something is moving? It only makes sense relative to something else. The road, the earth, the stars. Motion is always a comparison. Now here's where it gets even more interesting. Think about this. Right now, you feel like you're sitting still. But are you really? The earth is spinning at hundreds of meters per second. At the same time, the earth is orbiting the sun. The sun is moving through the galaxy, and the galaxy itself is moving through space. So right now, you are moving incredibly fast. And yet, you feel completely still. Why? Because everything around you is moving with you. So there's no noticeable change relative to your surroundings. Now here's the twist. If motion is always relative, then what about speed? We say things like, this object is moving fast. But fast compared to what? Without a reference point. Speed has no clear meaning. Even direction becomes relative. Forward, backward, left, right, all depend on how you choose your frame of reference. Now let's go one step deeper. You're in a car, moving at constant speed. A cup of coffee sits on the dashboard. It doesn't slide backward, it just sits there. From inside the car, it's at rest. From outside, it's moving with the car. So is the coffee moving or not? Again, both descriptions are valid, because motion is not a property of the object alone. It's a relationship between the object and the observer. Now here's where another misunderstanding appears. We often think that if something is moving, there must be a force pushing it. But that's not true. If you slide a puck on nearly frictionless ice, it keeps moving for a very long time. No continuous force is needed to keep it going. Forces are needed to change motion, to speed up, slow down, or change direction, not to maintain constant motion. This idea goes against everyday experience, because in real life, friction is everywhere. Things slow down unless you keep pushing them. So we grow up thinking motion requires force, but in a simpler, ideal case, constant motion continues on its own. Now take a moment to let that sink in. Objects don't need a reason to keep moving at a constant speed. They need a reason to change that motion. Now let's connect everything. Motion is relative. There is no universal standard of rest, and constant motion doesn't require a continuous push. Now imagine something extreme. You're floating in deep space. No planets nearby. No obvious reference points. Are you moving? There's no simple way to tell. You could be drifting slowly or moving incredibly fast. Without a reference, the question becomes difficult to answer. Now bring this back to your everyday life. When you say, "I'm sitting still," what you really mean is, "I'm not moving relative to my surroundings." That's all. Now here's the deeper insight. Motion is not something an object has all by itself. It's something we describe by comparing positions over time, a relationship between things, not an absolute label. So the next time you see a car speeding down the road, or feel yourself standing still, pause for a moment and ask yourself, moving compared to what? Because maybe the most surprising part of all is that motion isn't just about objects traveling through space. It's about how we choose a reference and how we describe the relationships between things in the universe.